Welcome back, everybody. Today we're going to wrap up our chapter on triangle properties with section 5.7. Okay, we're building off what we did in the last lesson, talking about inequalities once again. In our last lesson, we used inequalities to relate the sides and angles of one individual triangle, okay, to itself. Today what we'll do is use similar properties to relate the sides and angles of two separate triangles and use them to make some comparisons. Okay, so objective, to apply inequalities to two triangles. Let's get rocking and rolling with that. And so the big theorem we're going to be dealing with today is what we're going to call the hinge theorem. It says this: if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. Okay, so if I have two triangles, and these two triangles both have two sides congruent, so here we have BA is congruent to YX, and AC is congruent to XZ, and the angle between those two sides is not congruent, and in this case angle A is greater than angle X, what I know then is that the bigger angle is going to be across from the bigger third side, the smaller angle will be across from the smaller third side. Okay, so in this case BC is greater than YZ. Okay, so in other words, bigger angles are across from bigger sides, smaller angles are across from smaller sides. Same relationship we saw within one triangle, okay, with our theorems dealing with how we related sides and angles together in the last lesson. Okay, we're also just going to talk about the converse of that. This just says the same thing relating sides to angles rather than angles to sides. Again, if I had two triangles with two sides congruent, and I knew one of the third sides is greater than the other, so in this case BC is greater than YZ, well that means the angle across from BC, angle A, will be greater than the angle across from YZ, angle X. Okay, so we get the angle A is greater than angle X. Again, same relationship, bigger sides are across from bigger angles, smaller sides are across from smaller angles. All right, so let's look at how we can apply the hinge theorem to a few different problems. Problem 1, part A says, what inequality relates SK and UY? So in other words, the length of segment SK and the length of segment UI. When we say what inequality relates the two, that means we're going to say we have an SK and our UY, and we want to figure out what kind of sign can we put between the two of them, a greater than sign or a less than sign. Okay, well to figure that out, like we said, we can use the hinge theorem, and it will work for this problem because I have two triangles with two sets of congruent sides. So segment AS is congruent to segment OY, and segment AK is congruent to segment OU. They're both marked congruent. And the angles included between the two congruent sides are not congruent. Okay, A is 90, O is 70, so A is greater than O. The theorem said that since A is the bigger included angle, we know that the side across from it, SK, will be the bigger of the two third sides. Okay, so since A is greater than, SK will be greater than as well. SK will be the longer of the two sides. Okay, that's our hinge theorem in action. Part B is the same idea. I want you to take a minute, pause the video, work through that run, and then hit play to check your answer. All right, so let's run through part B. We want to relate LN and OQ. So in other words, LN and OQ, and we want to stick a greater than sign or a less than sign through them. Okay, I can use my hinge theorem because my first triangle has side lengths of 7 and 4. Same with my second triangle, side lengths of 7 and 4. And when I compare the angles then, angle M is the greater measure. It measures 125 as opposed to 78. Therefore, I know that LM will be the greater of the two sides, LN, sorry. So we can say LN is greater than OQ. All right, in problem 2, we have a pretty simple question, but it gives us a nice visual, a nice kind of concrete situation to relate our hinge theorem to. It says the diagram below shows a pair of scissors in two different positions. In which position is the distance between the tips of the blades greater? Okay, so these two scissors, we can make triangles out of the blades and the distance between the tips of the blades. Okay, so we have two triangles from the same pair of scissors, and we want to figure out which one has the greater distance between the tips here. And for this, since we're talking about triangles with congruent sides, the blades are the same on the two pictures. What we can do is we can look at the angles across from that distance we're looking at. Since 40 is the greater angle, I know that this distance will be greater between the tips in the second situation here. Okay, again, pretty simple problem, but it's a nice visual, nice way to think about how this hinge theorem works. All right, and last thing we're going to look at doing is bringing some algebra into the mix, okay, doing some solving for x. Problem 3 says, what's the range of possible values for x in this situation here with my two triangles? Okay, well, so when I say range of values, what I want to end up with then is x sandwiched between two numbers, okay, greater than some minimum and less than some maximum. That's my goal for this one. And to solve for that, here's how I can use my hinge theorem. I've got two triangles. They both have one set of sides marked congruent. And since they share a side down the middle here, I know I have a second side congruent. We know the angles, expressions for the angles included between those sides. Then we also know the measures of the third sides. And our hinge theorem says that the bigger angle is going to be across from the bigger third side. Okay, so since 15 is greater than 10, I know the angle across from the 15 to 60 is going to be the greater of the two angles. So the inequality I can set up then is that 60 is greater than my expression for the other angle, the 5x minus 20. Okay, so we're getting that inequality based on my hinge theorem. Again, bigger angles are across from the bigger sides. Smaller angles across from the smaller sides. And then once we have that inequality set up, we can solve it. Now I can solve this just like I do an equation with an equal sign here. I can do the same thing to both sides of the inequality to keep things balanced. So if to get the x by itself, I'm going to add 20 to both sides. And that's going to give me an 80 is greater than 5x. Next thing I'll do is I'll divide both sides by 5 to get the x by itself, which will leave me with a 16 is greater than x. Okay, so that's part of my answer. 16 is greater than x. In other words, x is less than 16. So 16 is going to kind of act as my maximum for this range here. Now the trick is I'm also going to have to find a minimum value. So what I need to do is think about what's the smallest this angle could possibly be in this triangle. Now an angle in a triangle has to be positive. I can't have 0, I can't have negative numbers. So what I can do for my minimum then is I can say that 5x minus 20 has to be greater than 0. And then I can solve that inequality to get my min. We'll do the same steps. I'm going to add 20 to both sides. That'll give me a 5x is greater than 20. Divide both sides by 5 to end up with x is greater than 4. And I'll plug that 4 in for my minimum value. Okay, so my range is complete. I know that x can be anything between 4 and 16 and make things work here. Okay, part B is the same idea. Why don't you take a minute, pause the video, run through part B, and then hit play, and we'll walk you through the answer, or you can use it to just check your answer as well. All right, so for part B, we've got congruent sides on our triangle and different size third sides. Okay, the bigger side is going to be across from the bigger angle, smaller side across from the smaller angle. So that's why for this one I can say that 90, the greater angle, is greater than 3x plus 18. We'll solve that inequality. I'm going to subtract 18 from both sides. That'll give me a 72 is greater than 3x. And then we'll divide both sides by 3 to end up with 24 is greater than x. All right, so 24 is going to act as my maximum value. Next thing I'll do is I'll set up the minimum. So if I have the max, the min's always just going to come from 0. Okay, the smallest this angle in the triangle can be is just anything above 0. So we can say that we have 3x plus 18 is greater than 0. And then we'll do the same steps to solve. I'm going to subtract 18 from both sides. That'll give me a 3x is greater than negative 18. And then as I run out of room here, we'll divide both sides by 3. And we'll work around my face. So x will end up greater than negative 6. Okay, so I have my minimum and my maximum. So final answer for this guy then is we'll put x between the 24 and the negative 6. Okay, so if x falls within this range, we'll have a triangle that actually works. Those are all my possible values. Let's take a look at one more example in part C and see how this can work out slightly differently. Same idea, I've got two triangles here and I want to come up with a range for my x values. So let's take a look here. This time notice the expression with the x is across from the larger of the two sides. Okay, so when I set this up, I'll have 2x minus 12 is going to be a bigger angle than this 36, which is across from the 5. So we can say that 2x minus 12 is greater than 36. Okay, so let's go ahead and solve that. I'm going to add 12 to both sides to get 2x is greater than 48. We'll divide both sides by 2. And end up with x is greater than 24. Okay, x is greater than 24. So what's the difference with this one? Notice when I use that other angle, that 36, I didn't find my maximum for this one. X is greater than 24 is going to be my minimum. Okay, so what I need to do then is figure out what the max is going to be based on what's possible in a triangle. Okay, so for that, if I think about what's the largest angle in a triangle could be, I suppose technically that's 180. But let's say based on this picture here, I can tell that this is an acute angle. It's not greater than a right angle. Okay, it's not obtuse. So let's say the greatest this angle could be would be 90 degrees. So I'll set up then to find the maximum is 2x minus 12 is less than 90. And I can solve that inequality to get my max. Again, we'll add 12 to both sides. That'll give me that 2x is less than 102. And divide both sides by 2. And end up with x is less than 51. Okay, so 51 is my max there. As far as when to use a 90 or when to use a 0, well, you have to ask yourself, do I know the minimum or do I know the maximum? If I'm trying to find a min, and I've already used the other angle in the problem, we'll use 0. If I'm trying to find the max after I've used that angle, we'll use the 90. All right, so that's it for lesson 5-7. Start cranking on the homework, start getting through some problems. If you need some help, we're here to help you out. Otherwise, we'll see you folks later.